Today, I would like to demonstrate an integrated usage of two edge solutions, Relay TinyAutomator and EdgeImpulse machine learning on a Raspberry Pi device. Those two solutions can work perfectly together on edge devices like Raspberry Pi, NVIDIA Jetson, and many other similar kinds of devices. During demo, I will go over two use cases: detecting the occupancy of parking places and alerting based on occupancy rate. And second case is detecting the absence presence of an item. I will use Mandarin in my case, and alerting about absence of that Mandarin. So let's get started. On my EdgeImpulse account, I have a couple of machine learning projects. One of them is recognizing the fruits. In my case, I took some pictures of mandarin and pear. I used my mobile phone camera, so took some pictures and labeled them. So you see images which I labeled. Then I also created a machine learning model. It is named Impulse on EdgeImpulse platform. And I did train my dataset using object detection model provided by EdgeImpulse platform. I also have another project which I did import from publicly available projects on the EdgeImpulse platform. It already has all data and trained model, so you see that it has quite nice performance accuracy. And I will be just using that trained model during my demo on my Raspberry Pi. First, I will use a parking occupancy model. So on my Raspberry Pi terminal, I will start an EdgeImpulse Linux runner in clean mode. So that will download and compile the trained machine learning model. So it asks for my credentials for EdgeImpulse platform. It also asks for a model which I want to use and a camera. Okay, then it starts downloading and compilation. And after some time in a browser, you can see the classification, live classification. So on my demo, I will use some chocolate bars as a replacement for cars, but nevertheless, the model recognizes pretty well the number of pseudo cars on an image, so I can use it during my automation. So the next process is integration of EdgeImpulse classification with Relay TinyAutomator automation rule engine. The EdgeImpulse platform provides a Node.js SDK library, and we can implement a Relay sensor using that Node.js library and perform classification inside the Relay TinyAutomator. Let me quickly first stop the Linux EdgeImpulse which was running. Okay, so Relay sensor is a serverless function which runs inside the Relay engine. And I created one special sensor, called it EdgeImpulse Photo. So that one executes a classification of image. This is using EdgeImpulse Linux Node.js library, and it has two parameters. One is a model file. This is an executable file which will be called during classification. So let's maybe quickly download that file for our project, for EdgeImpulse project. So it is saved as on your file system, and you have to copy it to the volume which will be used by the Docker container of Relay engine. So let me quickly check if we already have that file. So I'm just checking the content of volume which is used by our TinyAutomator sensor executor. Okay, so it is there, cars EIM file. Okay, so we have two parameters. Image file is actually the image which will be stored by the streaming container. So the complete process will be separated into the image capturing process, which will be done by a separate Docker container. It is a simple container which has a shell script which does image capturing on predefined intervals, saves the file on shared Docker volume accessible by both capturing Docker container and Waylay engine Docker container, and sends a message to the Mosquito MQTT server with a file name. Okay, so Waylay engine has a data ingestion layer which can listen to MQTT topics. So here, for example, I am listening for stream topic, and then it will inject that data towards engine for further processing. So let me show the content of that container definition. So this is a streamer container which contains utilities like FSWebCam and Mosquito client. So to FSWebCam to just get an image out of camera, and Mosquito is sent MQTT message. So that container has some mappings for devices, video devices, and also some parameters towards MQTT, like topic name which will be used, also delay at which pictures will be captured, and files directory where files will be kept, and volume which is mounted on Docker engine. Okay, let's start that streaming container. Okay, to start it, let's check the logs if it's doing something. I just for every capture, I just log the image to picture. Okay, and let's wait 3 seconds. Okay, picture is taken. So normally, yeah, you see that ingestion layer already taken messages. So you see that it has an image file name inside. So we can use it inside Waylay template. So I have a template which does image classification. So it's using the sensor which I created using EdgeImpulse library. So that one has 2 parameters, model file, or maybe first check the content of sensor once more and see what it does. So it initializes the Linux image EdgeImpulse runner. Then it prepares image which has been taken. So it resizes image according to the model requirements, according to model parameters, like making 320 image. And then it is resizing. And after resize, it calls the classification using that Linux EdgeImpulse runner, and saves the classification result as a JSON object. So next step is actually after classification, we just check the content of result. We see the bounding boxes array. And normally, if something detected, the classification result will contain that element, and we check the length of that array, and actually that will be a number of cars on an image, number of detected cars on the image. And based on that number, we can do some logic, condition logic, saying, okay, if number of cars on the image is greater than predefined requested number of cars on a task, using that variables on defined task, then we will create alarm if number of cars become too high. So if it goes from low to high, we will create an alarm. And that message will contain also number of cars. And once number of cars is reducing, so then its condition goes from true to false, then we will clear alarm based on that type, which is actually has the same value during alarm creation. So let's start our task. So here it is a task which is of type reactive. It means it's reacting on incoming data, and it has variables. So here you see the model name which we will be using, and also number of cars which will be used to trigger alarm. So if it's bigger than 4, we will see that alarm will be created. If it's less than 4 or equal to 4, then alarm will be created. So let's start the task. And now let's see how it behaves. So classification happened. We have 7 cars on my table. So let's see. Okay, first it has to go to the low. So let's reduce some number of cars. Okay, I just took off some cars. See how it behaves. Okay, so now it became false. So it means that number of cars now less. Okay, so it's 4. And now next step, I will add additional cars. Let me add additional cars and see how it behaves. So cars have been added. See logs. Still not detected. Or maybe just some UI issue. Okay, yeah. Now it's number of cars 7. So normally alarm should be already created. Okay, let's see the alarms. Yes, it has been created, and I see number of cars on the parking. It says that the parking is almost full. It has 7 cars. And you see some details of that alarm when it has been created. Okay, now it just let me remove some cars back. Okay, couple of seconds. And now on the logs, we see, okay, it's reduced to 3. And normally the alarms has to be cleared. Okay, it's gone. And on the result of alarms, you see that it is has been cleared. Also the time of clearance. So that was a demo of my car parking occupancy. Actually, you can also extend template if you want, for example, notify also using SMS. You can create, add additional elements to your template. For example, sending a Twilio, SMS via Twilio. Okay, so using same message, for example, and say, okay, you just can add number to which it will be sent, from whom it will send, was sent. Okay, so normally, yeah, but first you need to create, of course, a Twilio account. But anyway, so here you need to provide some credentials for communication with that service. Okay, next demo is quite also simple. So it's about that detection of object. So it's my Mandarin. So I had some data as I was already describing before. Okay, so this is my data for classification. So I have created also a model. I did train it. So you see the precision score, but it's not so good, but for our demo it should be enough. Now let me download it. So let me quickly download the same the model file for my second project. So I need to start again with clean configuration. So there I need to provide my credentials. Okay, choosing another project. Still using same camera. Okay, so git compile. Okay, so here I see quickly what it is detecting my fruit. Okay, let's stop it, and now download the file. So download the model file and copy it to the shared Docker volume. Okay, I also need to make it executable. Yeah, of course, it should be executable file, not directory. Okay, but directory is also okay. Okay, and now checking. Okay, it's changed to executable. Now I have also another template. Okay, so just need to start a Docker stream again. Okay. Okay, so you see streaming started, and now I have another template for my case. This one is simpler because I just need to see if there is a bounding box exists or not. So I use the same sensor because it's parameterizable, so I will use another um, parameter. And here I will just parse the result of classification and see if bounding boxes exist and that length of that array is 0. So if it's 0, it means it is doesn't exist. So it means, okay, I will create alarm if it became from false to true. So it means it was existing false, and true it was stolen. And then I can create alarm based on that condition. Okay, and just start task. It's also reactive. Okay. Okay, it's became true. Let's put some Mandarin and see what's happening. Okay, so the Mandarin is detected. Now, okay, let me remove Mandarin and see what will happen. So remove Mandarin. Okay, let's see what's happening. Okay, it's detected that is now false. I put back, and now it's removed. Okay, so alarm is created. My fruit was stolen. Okay, put it back. Okay, it's detected, so let's put back. And now let's see an alarm, so it is cleared. That is the end of my demo, and you saw the power of automation that comes to the edge devices. You can seamlessly integrate different solutions together, being very TinyAutomator and EdgeImpulse, for example, that can serve your needs. I will suggest you to try yourself, and for more information about installation and usage, you can go to our Edge automation part on our website. Thanks for watching, and see you next time.